If you're building modern .NET applications, you know that fear, right? That one single point of failure that could bring everything crashing down. You know, a slow API, a database that's struggling, and suddenly your whole system is at risk. Well, today we're diving into a really powerful pattern that's designed to stop exactly that. It's all about making sure your app stays afloat, even when things go sideways. This scenario, this is basically a developer's worst nightmare. Every single request starts to wait, your threads get totally consumed, memory usage just spikes through the roof, and before you know it, your app is just completely unresponsive. A problem in one tiny external part of your system has just caused a total system-wide outage. And that's really the core question, isn't it? If one part of your system springs a leak, how do you contain that damage so it doesn't just flood and sink everything else? The answer, and this is the cool part, actually comes from building real ships. To really get this pattern, we're going to step away from the code for just a minute and look at where the whole idea came from, the humble bulkhead on a ship. It turns out, this centuries-old engineering concept is a surprisingly perfect analogy for building software that can take a punch. It's such a simple but absolutely brilliant idea. You get a hole in one part of the ship and you seal it off. The water is totally contained in that one compartment, and the rest of the ship just stays buoyant and completely operational. And this is where it just clicks for software, right? Those watertight compartments, think of them like isolated resource pools in your application. Separate thread pools or connection limits for different services. And the flooding? Well, that's a cascading failure. That's what happens when a problem in one service overwhelms all your shared resources and takes down everything else. The bulkhead pattern literally stops that flood. Okay, so let's bring it back from the high seas to our actual code. Why is this isolation so critical for a modern .NET app? What are the real, tangible benefits we're going to see? The benefits are immediate and they are powerful. First, you contain failures. A slow component can't just hog all of your system's threads anymore. This directly prevents those dreaded cascading failures, which keeps the rest of your app nice and stable. So instead of a total crash, what you get is a smooth degradation of service. Only the affected part slows down. And ultimately, all of this adds up to a much, much more resilient and reliable application. All right, now for the really fun part. How do we actually build these watertight compartments in our .NET code? Thankfully, the absolutely fantastic Poly library makes this incredibly straightforward. Implementing this is way simpler than it sounds. It really just boils down to 3 steps. First, you install the Poly NuGet package. Then, you define your bulkhead policy. This is where you set the rules for your compartment. And finally, you just wrap the critical piece of code you want to protect with that policy. Let's see exactly what that looks like. So, when you create the policy, it all comes down to 2 key numbers. Think of maxParallelization as the number of active, concurrent actions you'll let through at any one time. Once those slots are full, max queuing actions creates a little waiting room for any new requests. Here's the kicker. Any request that shows up when both the active slots and the waiting room are full gets turned away instantly, protecting your system from getting overwhelmed. And using the policy is even easier. You just wrap your critical code with it, use execute async to run that potentially slow API call through the policy. This is what effectively places it inside that protective bulkhead. And that try-catch block you see, that is absolutely essential. It's how you decide what to do when your bulkhead has to say, nope, sorry, we're full to a new request. This exception right here,
This is the secret sauce to graceful degradation. When those execution slots in the queue are both jam-packed, Poly doesn't let a new request just hang there and consume resources. It immediately throws a bulkhead rejected exception. By catching this, you take back control. You can return a fallback response, log the issue, or just tell the user to try again in a moment, all without letting the pressure crash your entire system.
Okay, so you've got the basics down. Let's level up and look at some pro tips for making this pattern even more effective in a real-world production application.
This is absolutely crucial. Do not use a one-size-fits-all approach. Look at this example. You've got a high-risk, potentially slow payment service. That gets a very strict, very tight bulkhead policy, with only a few concurrent calls allowed. But then you have a fast, internal user profile service. That might get a much more generous limit, or maybe no bulkhead at all. You have to tailor the protection to the risk.
So to wrap up the best practices, always separate your bulkheads by workload. A call to a payment gateway is a completely different risk profile than a call to an internal cache. Next, you have to monitor your rejections. This data is absolute gold for tuning your parameters over time. And this is where it gets really clever. For ultimate resilience, you combine the bulkhead with other poly policies. Pairing it with a circuit breaker is a power move. It means after a few failures, you'll just stop trying to call that broken service for a while, giving it time to recover and preventing your bulkhead from filling up in the first place.
When you put all this together, the value is just crystal clear. This isn't some abstract academic pattern. It's a practical, hands-on tool that contains failures, protects the core of your system, and ultimately, it ensures a stable, responsive experience for your users, even when one of your dependencies is having a very bad day. So I'll leave you with this question to think about for your own projects. What is that one flaky API? That one slow database query? That one component that, if it went down right now, could sink your entire application? Because that's where you need to build your first bulkhead.